Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video number 5, why there is only one universe and many big bangs. If the meon hypothesis is correct, then the building blocks for any big bang will just be zero mass black holes that can unmerge. Since the radius of a zero mass black hole is 1 in any double adjusted SI-type units that would emerge, so would be the size of the charge and mass of those merged and unmerged meons. The result would be exactly the same as we already have, with exactly the same laws of physics and loop structures, with 1/6 charge sizes as the composite forms. However, depending on the inflation rates, each big bang would have different loop sizes, meaning different masses, and so different chemistry and emission and absorption spectra. This would mean that there are no extra compactified dimensions in which to hide any other properties or universes, and there would have been many big bangs throughout the infinite lifetime of our own universe. The existence of other big bangs with different property values, inflation caused loop sizes and loop pair numbers, is loosely equivalent to having many universes, except they are all within our universe using our only meon properties. This enables their identification through spectrum and redshift observations, which would not be the case for multiverses formed outside our own universe. The conditions for events that start off a Big Bang will have occurred many times during the existence of the universe. Those Big Bangs will be randomly distributed throughout the universe, and our own Big Bang is just a small fraction of the total volume of the universe. This is effectively a mixture of the inflationary and steady-state theories of cosmology. Whilst there may be many isolated Big Bangs whose light has yet to reach us, there will be overlaps with some. If, as hypothesized, there are 2 types of Big Bang, some objects from each type could be within the envelope of our own Big Bang. One type of Big Bang is where the amount of inflation is so large and the energy released in the change of loop masses from near Planck energy to very small mass, large radius loops is enough to overcome the gravitational collapse of those same small mass loops. This type of Big Bang will continue expanding until all its constituent loops have lost their energies to the background. Whether this is considered to be a failed Big Bang is unclear, because although it will have failed to continue existing, it will not have collapsed back onto itself. The second type is likely to be more prevalent, and is where each Big Bang inflation amount is insufficient to overcome gravitational collapse. The result will eventually be contracting Big Bangs that become collapsing galaxies and eventually massive black holes. These are failed Big Bangs, and our own is such a case in process. The presence of objects from either type within our own Big Bang envelope will be observable in unambiguously adjacent redshift sources that have highly different redshifts. The supposed fine-tuning of the values of many of the properties of our Big Bang may explain why it is as long-lasting and as large a volume as it is. Other non-appropriate values would have shortened the lifespan of other Big Bangs and turned them more quickly into failed Big Bangs. In terms of entropy, the viscosity energy lost by loops in motion through the background merged pairs will be passed initially to those merged pairs within the track of those loops, but will spread out from that path over time into the general background. The only instance where this may not be the case is where an energy concentration unmerges a first merged pair to spark off an inflation event. The randomness of the background merged pairs motions will ensure that such a Big Bang event does not have a zero probability. One measurable that emerges from inflation is the size of the electron loop. Since it is the smallest mass but largest radius of meon rotation, it will be the first measurable. It is expected that the radius will be approximately 1.7 times 10 to the minus 21 meters. This is almost measurable today. Related videos will be 7, what sort of properties could other Big Bangs have, and 17, redshifts and dark energy. Thank you for watching.